Okay, in this video, we're going to go over something called solving right triangles. And we're going to use trigonometry to do it, but we're also probably going to use the Pythagorean theorem. And in some rare cases, you can even use the geometric mean, but that's probably getting ahead of ourselves just a little bit. Let's talk about what does it mean to solve a right triangle. Okay, so you'll notice here I've listed some characteristics that are true for every right triangle. Now, clearly every right triangle is called that because it has a 90-degree angle in it, right? So that's called one right triangle. That's one of the characteristics. The other 5, because there's 6 total, are that opposite the 90-degree angle is what they call a hypotenuse, okay? And here it's labeled C, so that's always opposite, all right? The 90-degree angle. Then you have something that are called legs. The legs are the 2 other sides of the right triangle that are not the hypotenuse. Now, sometimes these are exactly the same size, and most of the time they're not. So that's why I've designated them as 2 different letters here. So we're going to call those 2 legs. And then you also have 2 acute angles, 2 angles that are not the 90-degree angle. And they're always acute, right? Because we know that if you add all the angles inside of a triangle of any kind, it equals 180. Well, if you subtract 90 out of that, that means that the other 2 have to add up to 90, right? And neither one of them can be 90 since you wouldn't have the third angle. So they have to be less than 90 degrees, which is the definition of an acute angle. Okay, so solving a right triangle means you're going to find all these 6 characteristics. Okay, now let me show you an example of how that works. And here we have, I'm going to put it down here in the corner, so it leaves me a lot of room up here to do some work. Now, notice that I already have 2 of my characteristics already labeled, and that's because you need to have some information or you won't be able to solve for the missing sides. So what we know so far is that our hypotenuse is 90, right? We know that one of our legs is 3 units, and our hypotenuse is 5 units. Okay, so let me go up here and write this out. So we know that the hypotenuse is equal to 5. We know that we'll call it the short leg is equal to 3. We know that the right angle is 90 degrees. And the long leg we still do not know. And we'll call this angle B is still unknown, and angle A is still unknown. So to solve for this particular right triangle, we still need to find 3 different characteristics. So let's strategize. How are we going to do this? Well, I know from the Pythagorean theorem that if I know 2 sides of a right triangle, I can find the third. Okay, so let's just do that. So let's find B. Let's find the short leg, or the long leg rather, B. All right. So I know that, and here I'm just going to do it this way. I'm going to label it actually. Solve for B. In this case, the B is the long leg. So I know that 3 squared plus B squared is equal to hypotenuse squared. Okay, let's solve. That gives me 9 plus B squared is equal to 25. Subtract 9 from both sides. I get B squared is equal to 16. Take the square root of both sides, and I end up with B is equal to 4. So now we have the long leg B is equal to 4. Now let's continue. And let me just go ahead and write that in there real quick. B is equal to 4. Now here's the trickier part. How am I going to find these 2 angles if I only know this one? All right. Well, I can actually use the relationship of the sides to the ratios of the angles, rather. Let me say that again one more time. The ratios of the sides are related to the angles, and that's what trigonometry is for. All right. So let's go ahead and solve for angle B, okay? And let's just do it that way. I always like labeling all my work so I know exactly what I'm doing. Remember, I'm really telling a story here, right? And this is like my introductory paragraph. This is like a paragraph working for one of the parts. Here's another paragraph working for another one of the parts. And I'm slowly filling in my introduction for a conclusion. But anyway, that said, let's go ahead and start using some of these ratios. Now, I remember that there's something called SOHCAHTOA. Let me see if I get it up there. There we go. SOHCAHTOA. And that basically tells me what the ratios are, right? I know that the sine of any angle is equal to the opposite over the hypotenuse sides, right? So the opposite side over the hypotenuse. Cosine theta, again, that just means any unknown angle, is equal to the adjacent side over the hypotenuse. And finally, I know that the tangent theta, again, of any angle, is equal to the opposite side over the adjacent side. Now, I happen to know all of my sides here, so I should be able to figure out both of these angles. So let's just pick one, okay? So to solve for B, let's solve for, we would know that the sine, let's choose the sine. The sine of B is equal to the opposite side over the hypotenuse. In this case, it would be 4 over 5. Okay? Now, how is that helping us? Well, let's reduce things. We know that the sine of B is equal to 0.8. Okay? But how's that going to work? Well, what I can do is I can multiply both sides by the inverse sine. Now, let me show you what that looks like. It looks like I'm saying sine to the -1, but that's not really I'm going to multiply both sides by this, actually, but that's not really an exponent, so be very, very careful. All right, that just means that it's the inverse of sine B, okay? And then so I'm going to multiply this side by the same thing. Now, whenever you multiply, if you remember your algebra, whenever you multiply by an inverse, it always cancels out to 1. So basically what I'm saying is that the angle B should be equal to the inverse sine of 0.8. Now this is where I need my calculator. So let's bring it up. Let's turn it on. Let me just clear this. And let me just make sure my mode is correct. Remember, always press the mode, which is, there we go, which is this little button right here, and then make sure that you are in degrees here, okay? And we are, so let's just go ahead and start working. So what I want to do is I want to find the inverse sine of 0.8. Now to do that, I go to the second button, I locate the sine button, and you'll notice right above it, it says inverse sine. So I go inverse sine, and this is what shows up on my screen. And then I just press in 0.8, okay? Press in the enter. It tells me it's 53.13 degrees, all right? So angle B basically is just equal to 53.1 degrees. And let me just put that in there. 53.1 degrees. Now, I can actually solve for angle A, which is this angle down here. Let me just write this one in here real quickly. I know that this is 90 I just calculated this as 53.1. Now I should be able to find out what this one is simply by adding up 90 plus 53.1 plus my unknown, we'll just call it x, and I know that that is equal to 180 degrees. That's just a triangle angle theorem, right? So let's add all that up. So 53.1, I'm just going to round that, plus 90. Oops, sorry, that's off camera there. There we go. Is equal to 143.1. And let's just go 180 minus 143.1. And that gives me 36.9 for my missing angle. Okay. Now, normally I would say we are good to go here, but let me just write this in. But we should always try to corroborate and just to make sure that this is correct. Now, how would I do that? Well, I could basically just try another trig function. So let me just show you. So I'm going to solve for angle A. And I'm just going to use another one of these trig functions to solve. Because remember, I know all my sides. And I'm going to go, let's just see, how about adjacent, opposite over adjacent, which would be the tangent function, right? So let's just say that the tangent of angle A is equal to the opposite 3 over the adjacent 4. I know that that's equal to 0.75. I'm going to multiply both sides by the inverse tangent, right? So let's just go tangent, inverse tangent of tangent A, and multiply this side by the same thing. Okay, let's go ahead and we know that this cancels out to 1, so I'm left with just angle A should be equal to, let's go to my screen. Let's press clear. I know that the second tan, all right, so again, make sure you press that correctly. Second button and then the tangent gives me the inverse tangent. So second tangent of 0.75. And if we did this correctly, it should be equal to 36.9. Let's see what happens. Sure enough, 36.87, which rounds to 36.9 degrees. Okay, so I hope that was helpful. Really, the gist of this is that when you solve for a right triangle, you need to find all 6 of these characteristics. Usually you're given 2, sometimes 3. Depends on what it is. You could be given sides, you could be given an angle and a side and another angle. It really just depends. But then you have to strategize about how you're going to find it. Okay? Do you want to use the Pythagorean theorem, as we did over here? Or do you want to find the sine of a function, sine of an angle rather, the tangent of an angle? It just depends what works for you. Okay? I hope that was helpful.